Hello, in this session we will take up a question on kinematics taken from the Pathfinder book. It must have appeared someday in some Olympiad. So here is your question. A boy runs on a circular path of radius capital R, that is 28 meter, with a constant speed of u, that is 4 meter per second. Another boy starts from center of the path to catch the first boy. The second boy always remains on the radius, connecting the center of the circle and the first boy, and maintains magnitude of its velocity a constant of 4 meter per second. In fact, u and v are same. How long is the chase? After how much time the second boy will be able to catch the first boy? That is the question. Please give it a try on your own. I am getting out of the screen for a moment. Capture it and just try to understand what the question is trying to say. Here I proceed with my solution. The question becomes instantly easy if you realize that the angular speed of the two boys about the center of the circle is same. That's all. Question is solved. There's a boy running on this circular track. Let us call it boy A. Initially boy A is here, boy B is here at the center. Obviously boy A is running with constant speed on the periphery and boy B is trying to catch him. So initial velocity of boy B is obviously towards A. But as A shifts position, B has to change direction. So B must be traveling on a curved path like this. This is just an indicative path. At an instant when boy A is somewhere here, the boy B must be here, because the question says that boy B always lies on this radial line, the line joining the center to boy A, radius. So boy B always lies on that center. So if, let us say for example, boy A has rotated through 60 degree, in the same time interval, B has also rotated through, or B has changed its direction of velocity through 60 degree, isn't it? So if A goes here, B will be somewhere here. So this angular displacement for A as well as B is always same. What is, if I may call this angle as theta, d theta by dt is angular speed of boy A, and its magnitude must be equal to u by r. He is running with a constant speed. So the angular velocity of boy B must also be this much. That is the key thing to understand. If you have got it now, give it a try again. I'm just showing boy B in some random position, some intermediate position rather. When boy B is here, his velocity obviously is somewhat like this, tangential to his path. Now this velocity has got two components. One component that is perpendicular to radial line, let me call it as V perpendicular. You may also call it as V theta, V perpendicular. And then there is a radial component, VR. So velocity of boy B can be resolved into two components, V theta or V perpendicular and VR. And what you need to understand is that this V perpendicular is nothing but omega into r, where r is this distance. Both the boys are having same angular speed about the center point O. The angular speed of boy A is known, omega is known. This boy B is also having same angular speed. So when a particle is moving on a curved path with reference to this fixed point, how will you define its angular speed? This is the position vector. Perpendicular to this position vector, take the component of velocity. This velocity component by r, this is angular velocity. This is the rate at which this theta angle is changing. And velocity component in the radial direction is basically radial velocity, which is dr by dt, the rate at which this distance is changing. So V perpendicular is known to us when the boy is at a distance r from the center, boy B. But he is moving at constant speed, right? So magnitude of the velocity is V, which means VR square plus V perpendicular square is always equal to V square, which is a constant 4 meter per second. So this quantity is changing with r. Omega is constant, but distance is changing. So this quantity is changing. This is constant, this is changing. So this must be changing. How is VR changing? V square minus this omega square r square root. And now what is VR actually? VR is rate of change of this r. dr by dt is VR. So dr by dt is nothing but this much. So this kind of coordinate system is basically plane polar coordinate system. Here we are indicating the position of a particle using two numbers, r and theta. Let us say this is the reference line. When you ask me where is this particle, I tell you two numbers, theta and r. I say that rotate 60 degree from this reference line. Now move 2 meter from here and you will reach that point. So just in Cartesian coordinate system, just like in Cartesian coordinate system, in a two-dimensional motion, you break the velocity into two perpendicular components. Same thing is being done here. If the velocity is this way, we have broken it into two components which are perpendicular. One along the r, another perpendicular to r. This component that is perpendicular to r, this VR is actually omega into r. This V theta or V perpendicular is actually omega into r. And this VR is dr by dt, the rate at which this distance r is changing. So because this is known to us now as a function of r, because we know that resultant is V, therefore we know the value of VR, and VR is dr by dt. So just by separating the variables and integrating, you just need to perform this integration. Time 0, this r was 0, boy was here. At time t, the boy is at a distance capital R from the center. When the boy B is at a distance capital R from the center, he is exactly at the position of boy A, right? So that is what you want. So this integration can be done by simple substitution. The substitution that is required is you have to assume that omega into r is V sin theta, right?